Hello grade 9 learners, we're back for another exciting math lesson. After knowing the important characteristic of the graph of quadratic function, you are now ready to analyze the effect of the changing values of a, h, and k in the equation y is equal to a quantity x minus h squared plus k, or f of x is equal to a quantity x minus h squared plus k. First, the effects of h and k to the graph of a quadratic function f of x is equal to a quantity x minus h squared plus k. We need to focus on k in f of x is equal to x squared plus k, or f of x is equal to quantity x squared plus 0 plus k. In this function, we are considering how a positive k value changes the graph of a basic quadratic function. In analyzing the effect of positive k value, we have the parent function, which is x squared, and this is the graph of x squared with the vertex of 0, 0. Now, let's take a look if our k is positive 3. So we have x squared plus 3, and the graph looks like this. The vertex is now at 0, 3. How about if our k is positive 5? So we have x squared plus 5, and this is the graph. The vertex is at 0, 5. Now, what have you noticed? Very good. The graph shifts up, or the graph shifts upward. Therefore, the positive k value shifts each graph up. Now, in this function, we are considering how a negative k value changes the graph of a basic quadratic function. Again, let's graph our parent function, which is x squared. Then, if our negative k value is equal to negative 2, the equation will be x squared minus 2. The graph of x squared minus 2 is the red line on the graph. It has a vertex of 0, negative 2. Now, how about if our negative k value is equal to negative 5? So our equation will be x squared minus 5. And the graph of x squared minus 5 is this. The vertex is 0, negative 5. So, as you can see, the graph shifts downward. Therefore, the negative k value shifts each graph down. Next, focus on h in f of x is equal to quantity x minus h squared. Consider the expression x minus h and how the value of h appear when the expression has been simplified. If the value of h is equal to 1, we have x minus 1. And if the value of h is equal to negative 1, we have x plus 1. Now, we are considering how positive h value changes the graph of a basic quadratic function. Again, first is to graph our parent function, which is x squared, which has a vertex of 0, 0. Next, if the value of h is positive 3, the equation will be quantity x minus 3 squared. And the graph of quantity x minus 3 squared is this. It has a vertex 3, 0. How about if the value of h is equal to 5. We have the equation quantity x minus 5 square. And the graph is this. The vertex of this is 5, 0. As you can see, the graph moves to the right of the Cartesian plane. Therefore, when our h is positive or our h has positive value, the graph shifts to the right. Now let's take a look if our h has negative value. Again, let's have our parent function, which is x squared. And how about if our h value is equal to negative 2? The equation will be x, or quantity x plus 2 square. And the graph of quantity x plus 2 square is this. The vertex is negative 2, 0. Now, how about if our h value is equal to negative 5? The equation will be quantity x plus 5 square. And the graph of quantity x plus 5 square is this. Its vertex is negative 5, 0. Now, what have you noticed on the graph of negative h value? Very good. If positive h value shifts the graph to the right, negative h value shifts the graph to the left. So the negative h value shifts its graph to the left. Now we are done to the effects of h and k to the graph of a quadratic function, wherein the horizontal shifting of the parabola to either left or right depends on the value of h, while the vertical shifting of the parabola to either up or down depends on the value of k. Now let's move to the effects of a to the graph of a quadratic function. Let's take a look of the graph of f of x is equal to a, quantity x minus h squared plus k, where a is greater than 1. For our first equation, we have quantity x plus 2 squared minus 5, where a is equal to 1. So the graph of quantity x plus 2 squared minus 5 looks like this. Next, let's have the equation f of x is equal to 2 quantity x plus 2 squared minus 5, where a is equal to 2. And if the value of a is equal to 10, we have the equation 10 quantity x plus 2 squared minus 5, and the graph looks like this. So for the first equation, our a is equal to 1. For the second equation, our a is equal to 2. And for the third equation, our a is equal to 10. So from the graph, we can conclude that as the absolute value of a increases, the width of the graph becomes narrower, and a positive a value makes the parabola opens upward. Now let's have the graphs of f of x is equal to a, quantity x minus h squared plus k, where a is less than 1. For the first quadratic function, let's have f of x is equal to quantity x minus 4 squared plus 3, where a is equal to 1. So we have the graph of f of x is equal to quantity x minus 4 squared plus 3, where a is equal to 1. And then, let's take a look what will happen if the value of a will be less than 1. So for the second equation, let's have f of x is equal to negative 2 quantity x minus 4 square plus 3. And the graph like this. Now, let's see what happens if our equation will be equal to f of x is equal to negative 10 quantity x minus 4 square plus 3, where our a is equal to negative 10. So this is the graph of f of x is equal to negative 10 x minus 4 square plus 3. So from the graph, we can conclude that as the absolute value of a decreases, the width of the graph becomes narrower, and a negative a value makes the parabola opens downward. To sum it up, the positive k value shifts each graph up, while the negative k value shifts each graph down. The positive h value shifts each graph to the right, while the negative h value shifts each graph to the left. As the absolute value increases, the width of the graph becomes narrower, and the positive a value makes the parabola opens upward. While as the absolute value of a decreases, the width of the graph becomes narrower, and a negative a value makes the parabola opens downward. And that concludes our lesson for today. I hope you learned something. Thank you for watching. Keep safe and God bless.